Hello, Dr. Harris. We're back with talking about the tidy data chapter in our data computing course, chapter 5. Our last video, we talked about the command pivot longer. And in this video, we're going to be talking about pivot wider. And so we'll briefly look at the example that we were talking about previously in the last video involving the fasting data. Fasting narrow was the result of applying pivot longer to our original fasting data set. But I'll just point out that pivot wider can undo a pivot longer. And that's what we can see here. There are only going to be two arguments to a pivot wider command as opposed to the three that we had in pivot longer. We have a names from and a values from. Instead of names to and values to, it's names from, values from. And so we give it variable names. Where are the data heading, the column headings for our wider table coming from, and where are the values that are going under those column headings coming from as well. And so we can see that if we do pivot wider with a names from equal to when and a values from equal to wait, that we get the original fasting table that we had. So here's just a thing that you might consider doing sometimes with a pivot wider if you want to come up with slightly more descriptive names for your column headings in the wider data set. Instead of leaving it as before and after as our column headings, we could add a prefix using names underscore prefix as another argument in pivot wider, wait underscore, and that will attach a wait underscore ahead of our previous variable names. So we get wait before and wait after, somewhat more descriptive. So that's an option that you want to be thinking about. So names prefix is a nice way to possibly handle that. But let's look at another example where we're going to pivot wider. And it involves our baby names data. And so what we're going to do is we're going to look at just babies that have been born since the year 2000. We're going to group by the baby's name and by their sex, and we're going to identify how many babies there were by sex with each of those names. And so if I run this command and store it in a variable called recent babies, the first 5 entries in recent babies would look like this. So not surprising, we're going from the head of the alphabet, so there are a few names here that start with AA. And so one of the reasons why we wanted to do a pivot wider is to do computations on data. And so if we're going to be trying to answer this question, which common baby names since the year 2000 are the most gender neutral, we're going to want to perform computations by looking at the number of babies that are males that have a given name and females that have a given name. And it's going to be much easier to do computations if we've got things in a wider format. And so to do the computations, we would like to get for those names that have both male and females that were given that name, we'd like to have the male count and the female count in the same row. And so this is a case for a pivot wider. And so we're going to take recent babies and we're going to pivot wider with the names from, we're going to get the names from the sex and values from total. And so that will give me a male heading and a female heading in the same case. And this will migrate the number of males and number of females into the corresponding columns. So I invite you to play around with this a little bit to make sure that this does give you what you want. But if we ran this, recent babies wide would indeed have a name and then the number of males that had that name. And if there were no females, then it would give an NA. And so we can see that actually among these first 5 names, none of these were given to both males and females. But I'd like to get rid of the NAs. How can I do that? Instead of NA, we'll just put a 0 in. And so we can add another argument to pivot wider called values fill. And we'll just say that since values from is going to be the total that we have here, we go back to this data set. We got things in the total column. And so when we pivot wider, we're going to fill in any NAs. Values fill will fill in any A's with whatever we tell it to do, and we're going to put a 0 in case of any NA in this case. So when we run this command, we do have zeros here instead of NAs. That's going to be useful to us when we get to to answer our question about gender neutral. And so if we wanted to think about common baby names, we'll set it, that's sort of arbitrary what makes a name common. We're going to set an arbitrary threshold that it had to have both at least 1,000 males and 1,000 females with that name since the year 2000. And so we can filter on this. We could have put an and here instead of a comma, but we have a condition that both the number of males and the number of females must be more than 1,000. So we're going to call that data set common. And so we need to come up with a measurement of gender neutrality. And the way we can decide if a name is gender neutral or not is if the same proportion of males are given that name as the percentage of males in the population. And so since boys and girls are roughly 50-50 in terms of births, we're going to say that a name is gender neutral if the number of boys is about the same as the number of girls born over that time period. So we're going to let F be the number of girls with a given name, M be the number of boys with a given name. And so we like to compute to measure our measure of gender neutrality is going to be the smaller of the ratio of males to females and females to males. The smaller is always going to be this. The smaller of these two numbers is always going to be a number that's less than or equal to 1. And so, but the closer that the ratio, the smaller ratio is to 1, the more gender neutral the name is. So let's look at a computation, how we're going to do that. So one name that has at least 1,000 of each gender born since 2000 is the name Leslie. We can see that there are 1,359 males and over 39,000 females that have been born with that name or given that name after being born since the year 2000. And so if I want to use the console to compute the ratio, the gender neutral score for the name Leslie, I'm going to take the number of males to females and the number of females to males and find the minimum of those numbers. If I'm going to do this outside of a single command like this, if I've got just a data set called Leslie, then it's just a one-row data set now, and then there's a column heading M and a column heading F. The way I can reference those is with $signs. And so if I want the value that's stored in the column M for Leslie, I can refer to that as Leslie $M. Likewise, Leslie $F is going to be the number in the F column for Leslie. And then I can compute the other ratio. And if I run this over in my console, I see that ratio, the minimum of that number is about 0.034. That's a pretty small number. It's not particularly close to 1. And we shouldn't be surprised by that because there are many, many, many more females that have been given the name Leslie since 2000 than males. We could do Robin as well, and I'll let you do this yourself. There are still more females than males being given the name Robin since the year 2000, but you can find out that ratio is closer to 1. It's going to be, if you do this computation for Robin, you'll discover that the number for the minimum number for Robin is higher than that for Leslie. And so we would say that Robin is more gender neutral because the proportion or the ratio of males to females is higher than that of Leslie. But so what I'd like to do is I'd like to compute this measurement for all the names in our common file. And so what we want to do is we want to create a new variable. So we're going to use the mutate command. We'll call it gn measure, so for gender neutral measure. And we need a data verb called pmin. And so pmin of m over f, f over m, and then we're going to arrange in descending order by this gender neutral measure. And what we discover is that the most gender neutral name since the year 2000 in the US is the name Gentry. And it's very, very close to even. Justice is also very close to even, but not quite as close. Baby, I suspect, is not actual name given, but it's probably referencing a child whose name was delayed in being bestowed upon them. And so we see that those are roughly the same for both males and females child. And then Jules and Marion round out our top 5. And so the reason why we pivoted wider here was so that we could do this mutate. It's going to be much easier to do computations in a wider format. It's going to be easier to do graphics in a narrower format. So just a little bit more about pmin. If you give it 2 sets of numbers, it's going to find the minimum value for each pair of the 2 numbers. And so, that's why we're using pmin as our verb in this case. Just to go into a little bit more detail, m over f is the male to female ratio. F over m is the female to male ratio. And so one of those numbers, if they're not equal, one of those numbers is going to be bigger than 1, one's going to be less than 1. We're always going to choose the one that's less than 1. So that's why we're choosing the minimum, less than or equal to 1. And so we can expand this. We can actually, just to verify what's going on here, we can mutate our common data set a little bit more by creating 2 other variables, m to f and f to m. And then we'll add another column that measures the minimum of those. And then we'll just select a few of the variables from that. And if we run this command, we'll see that we haven't arranged this in descending order this time. And so we can see that Addison's, we have, if the ratio is bigger than 1, that means that there's more of that, the bigger the one in the numerator. So there are many more females, about 22 times as many females being given the name Addison since 2000 than males, but about 43 times as many males being given the name Adrian as females, etc. But our general neutral measure is picking the smaller of these 2 numbers in every case. We'll come back with another video shortly in which we look at another example using our pivot commands.